მაკა გამარჯობათ, როგორ აღარ? რაიც აგერ ახლა სამსახურში ვარ ლექცია მქონდა. მაკა ეს ლა თქვენ ელაპარაკეთ ნიკოლას. ხო, კაი. ეხლა რა მაინდა? ეხლა არ არის ინსტიტუტში, ვიცი. ეხლა მე რაც ვნახე, ეს ახალი ვერსია თუ ნიკოს ვერსია? არა, უბრალოდ იმიტომ შეიძლება ძალიან კარგია, მაგრამ მაგას ვერ ისწავლის მედიცინის სტუდენტი. არა, მაგ რო ვისწავლო მეც მჭირდება დაჯდომა და გარჩევა. და თან მე ახლა ფიზიკოსი ვარ, ხო, ამას ვერ ისწავლის მედიცინის სტუდენტი. არა, მოცულობა და ეს დაწერილი, არა, ესა დაწერილი ფიზიკის ფაკულტეტისთვის. ინჟინრისთვის და არა ექიმისთვის. არა, ჯერ ერთი რაში მჭირდება და მეორე მაგას ვერ გავიგებ, იმიტომ რომ მაგის ცოდნა არა მაქვს. აზროვნებაც არა აქვს მაგას ისეთი, როგორც ეს რო გაიგო. და მე ეხლა ვთქვათ გული, რა თუნდა ეხლა ეს გული ისწავლეს ეხლა რატო ვიმეორებ გულს. არ ვიცი, არა მგონია მე ჩემი ვერაფერი. მე ასე არა. არა, ნახეთ ჩემი წიგნი ხო გაქვს. არა, ეხლა იქ არის მე ასეთი მე მაქვს ეს რეოლოგია და სისხლის მიმოქცევა და სუნთქვა, მაგრამ მე მაქვს სხვანაირად. მე მაქვს ისე რომ გაიგებს ექიმს, მაგრამ უფრო ღრმად ვიდრე ექიმებს ასწავლიან, ანუ ფიზიკური თვალსაზრისით. მე მაქვს სულ სხვანაირად, უბრალოდ გადახება. არა, ეს კი ბატონო, მე ველაპარაკე იმ თამარს და კი ბატონო, მაგრამ ეს ამას უბრალოდ არ დაამტკიცებენ, მაგრამ მე არ დაამტკიცა და მაგაში ვერ თანხმები ირინას, რომ არ დაამტკიცა. მეც არ დავამტკიცა, მე რო ვიყო მაგის რეცენზენტი. ხო, კი ბატონო. კი. აი მე რო ვიყო მაგის რეცენზენტი პირველ რიგში, აი პირველ მე არ ვიცი, არ წამიკითხია, ხო? ვიტყოდი რომ ეს არის წიგნი არა სამედიცინო ფაკულტეტის სტუდენტი. ხო, ეს ეთყობა მან გადათარგმნა, ან ვათარგმნენა ვიღაცას უცხოური წიგნი. არა, ეს არის აი ალბათ 2009-ში, კი ბატონო. შეიძლება რუსულიდან არ ვიცი. ნუ ალბათ იქიდანაც არის, კი ბატონო. არა, კი ბატონო, უბრალოდ გეუბნებით, ამ წიგნს არ დაამტკიცებენ. ხო და აი ახლა არის რამე, უნდა ნახოთ რაღაც ანალოგი, რომ იმითი ვიხამძვანე. არა, კი, მაგრამ ის თავები ძალიან კარგია, ეს მე ძალიან მომეწონა, მაგრამ იმის თავების თავიდან რო არ წეროთ რაღაც თავების თარგმა. ის თავები თარგმანი, რა ვიცი, თქვენ გააქვთ, თქვენ არ გქონდათ ეს კურსი და გააქვთ მაგისთან ქართული. ვინარკი. ხო და იმიტომ უნდა ავიღოთ მე ახლა ჩემი წიგნი რო დავწერე. ხო და ну ეს კი, მაგრამ ძირითადი მასალა უნდა ისა. ხო, კაი, უნდა შევხვდეთ მაშინ, დაურეკეთ კითხები. უნდა ავიღოთ მაგის ნებართვა, რომ რაღაცა სწრაფ. აი, იქ უკვე შეიძლება ჩემი ავიღოთ როგორც საფუძველი და გადავაკეთოთ კი ბატონო, მაგრამ ის არის სამედიცინოსთვის გასაგებად დაწერილი. მაგ ეხლა გეუბნებით პათოფიზიოლოგიის კათედრა მოვიდა ჩემთან, ვიცნობ მაგათ ყველას ვეხმარებოდი და მითხრეს, რომ შენი სისხლის მიმოქცევა ჩვენ ვიყენებთ პათოფიზიოლოგიაში. არა, ხო და არა, გასაგებია და იმიტომ გეუბნებით, რომ ამ ისე იგი მაგათ ეს ესმით და მოსწონთ და ესმით, რომ ჭირდებათ და ეს უნდა იყოს. ეხლა ნიკო ვერ გააკეთებს მაგას, იმიტომ ნიკო სხვანაირად აზროვნებს. ეს არის სხვა ფიზიკოსები, აი მე ხო ვიცი ფიზიკოსები, აი ვინც არიან სულთან. მე უბრალოდ ძალიან დიდი ხანია მუშაობდი იმაზე, აი პერზე რომ მუშაობდი, მე ყველა იმას პათოფიზიოლოგებს, ყველა ექიმებს დისერტაციებში რომ ეხმარებოდი, მე თან მონაცემს კი არა, მე მაგას წერდი. და თან შედეგების ასახსნელად ძალიან ბევრს კითხულობდი. და მე პათოფიზიოლოგიის გრიფიც მაქვს. ანუ აი იმათ არ შეუძლიათ ასე აზრობდნენ. ხო და ეხლა უნდა შევხვდეთ და დროზე რაღაცა რო დავეწყოთ. არა, თანაც ეხლა სილაბუსში მიუთითებს უკვე ამ წიგნს და იქნება ისა, თან იქნება, რომელიც არის ბიბლიოთეკის საიტზე. ანუ ეს ნებისმიერი აკრედიტაციისთვის ეს გამოსადეგია. ხო და აი ეხლა რუბინი მაქვს, მე რაღაცა მე არ ვამბობ, რომ რუბინი გადათარგმნა, მაგრამ რუბინმა თვითონ მაჩუქა ეს წიგნი, მაგრამ მაგ წიგნი ვერ გამოვიყენე მე ბიოფიზიკის წერის დროს. იმიტომ რომ ეს არის ფიზიკა და არა მედიცინა. სამტომეული. რა თქმა ეს წიგნები? არ გვინდა ეს წიგნები ჩვენ ხო და აი მოველაპარაკეთ თქვენ მაგას მოველაპარაკეთ როგორც არა ლექციები არაა, გამოცდებიც არა აქვს, მაგრამ იქნება მოვიდეს ერთხელ, თუნდაც მარტო იმისთვის რომ შევხვდეთ. უთხარი ხო, გამოჩდით და უთხარი რომ მე მინდა ერთად დავჭდეთ ქაბატონ თამარსაც ვეთქვი და გადავწყვეტოთ რაც ვაკეთებ. Guy, no more student? Okay. As you know, this week you have an oral test. A lot of students wrote me what oral test we have. Before the holiday, I informed you that your oral test will be on the hydromechanics, blood circulation, and respiration. Do you remember?
Yes.
Yes.
Yeah.
So
Yes.
it has not to be the questions. Now, also you will have a written test, MCQ test on the whole material from the thermodynamics, including the respiration, but not this week because we will finish oral, and next week you will be informed about the data when you will come and write the written test, MCQ test. And today I will begin the new topic, which you will pass next week. This is electricity and magnetism. Is this clear?
Yes. Yeah.
Very good, it is clear.
Excuse me, Professor.
Yes.
Professor, for the final, we'll be having both oral and written.
Both final. Also, I many times explained you that the final exam will be mixed. Written 15 score or MCQ test, 100 tests, and oral 25 score. But let's pass our second oral test after written and study. I'm not pleased by your studying before this part. Some came later, some has to study for post major, but now we have to everybody be in line and begin a new topics, the electricity and magnetism. Do you know that the electricity is a new properties of the some of the particles, bodies, which was discovered in the 19th century. It was shown that except the mass, the some body has additional property, which was known as a charge. There are two opposite charge known as a negative and positive charge, and the charge are interacting with each other according the Coulomb law. Here you can see this Coulomb law, which force of the interacting charge particles is proportional to the. It is too late, and I will not admit your calls. Is this clear? Half hour is gone after the lecture was begin. I was waiting for you, and I will not answer on your calls. Okay, so listen, please. And please also check your scores in the classes activity. With your scores, and most of you will not attend the exam, will not be able to attend the exam. The interaction of the electrical charge particle is may be calculated according to the Coulomb law, where the Q1, Q2 is the amount of the charge, and R is the distance between the interacting particles. As you see, the force of the interaction is proportional to the charge and inversely proportional to the distance in the square. In this case, the coefficient K is the coefficient proportionality, where it is equal 1 by 4 pi epsilon 0. Epsilon 0 is the constant. This is the formula of the interaction of the charged particles in the vacuum. It was shown that the strength of the interaction is different in the different medium, and in all physical medium, gas, liquid, and solid, the strength of the interaction is lower as in the vacuum. That's why it was introduced the coefficient of the dielectric permeability, epsilon, which shows how weak is the interaction of the two charged particles in the given medium in comparison to vacuum. Is this clear?
Yeah.
Yes. Also on this page, the picture, you can see that the two same charge particles, positive or negative, are repelling each other, and opposite charge particles are attracting each other. The strength of the interaction increases with the increase of the size of the charge and inversely proportional to the distance between the interacting particles. If you will look on these two formulas, what is it? This is Coulomb law, and this is the gravitation force, yes, which is also proportional to the masses of the interacting body and bodies and inversely proportional to the distance between them in the square. You can see that there are also the coefficients K and gamma. K for the column is 10 in the 9 power Newton meter square by column square, and G is the 667 10 minus 11 power Newton meter square by kilogram. As you see, the G coefficient is much more smaller as the coefficient of the column formula. That gives us information that the gravitation force is much more weaker as electrical interaction. Is this clear? By
Yeah.
they are working
Yes.
by the similar manner, or they both of them are proportional to the magnitude of the charge or mass interacting bodies, and inversely proportional to the distance between the interacting bodies. That means that the strength of the interaction will be never equal zero. It will be infinitely decreased, became negligible on the infinitely high distance, large distance, but never will be equal zero. Is this clear?
Yes.
Yes. No, for the as the charge particle interact with each other with the force, we have to and they can do this on the distance. This means that they supply the area surround them with the specific properties which gives them a possibility to sense each other, to interact with each other, to influence on the charge particle, put it placed near the another charge particle with the repelling or attractive forces, supplies this charge particle with energy. That's why we have to call this property, which is supported for the medium by the charge particle, the field. Yes, is this clear? And the electric field can be introduced graphically by the force lines of the electric field, which show the direction of the influencing forces and also show the energy of the area in the given point of the field. It was used that the force line usually are begin from the positive charge. It was said that it is so. And so they will be finished in the negative charge. They are shown the direction of the force line of the electric field as they are beginning on the positive charge. They are going out of the positive charge and they are going inside the negative charge. And the density of the distribution of the force line of the electric field is proportional to the strength of the electric field. As stronger is the electric field, as more dense will be force line of the electric field. By this way, it is clear that the electric field of the point charge is non-homogeneous, yes, where the electric field of the point charge is stronger, near the charge or away of the charge. How do
Near
you
the
see?
charge, near the charge.
Near the charge, okay. Okay. No, you can see that the opposite charge can repel each other and attract each other, and same charge repel each other. On the next oral and written test, you will have the pictures where will be not indicated the charge, but will be indicated the direction of the force lines, and you have to indicate the charge. No, it is clear. If this is not difficult, if you will take in attention that it was said that the force line of the electric field are beginning on the positive charge and end of the negative charge. Now we have to characterize the electric field. Electric field can be characterized by the two types of the parameters. They are the forced parameter, it is the strength of the electric field, and energetical parameter, its potential. What is the strength of the electric field? E. It is a force by which the electric field influences on the point positive charge placed in any point of this field. As it shows as the magnitude of the force, also its direction, it is what? It is a vector, yes? Strength of the electric field, it is vector. The potential of the electric field is the energetical characteristic of the electric field. It shows what work must to be done to take the unit of the positive charge or echelon charge from the infinity in the given point of the electric field. Or it is scalar and it is equal A from infinity into the given point by Q. Is this clear?
Yeah.
Yes. So electric field obeys the superposition principle. Summation of the different charge electric field strengths is possible, and it will be summated by the vector algebra rules. Look, you can see here that non-homogeneous field is characterized for the point charge, but between the two positive charge plates, parallel plates, what we have? Which field we have? Homogeneous or non?
Homogeneous.
Homogeneous.
Homogeneous. Out of the two parallel plate, field will be, electric field will be non-homogeneous. We have to introduce the parameter, the equipotential surface. The equipotential surface are the surfaces which have the same potential. No? From this, it is clear that the same potential for the point charge will be what? The point which will be placed on the same distance from the point charge, or they will be placed on the surface of the sphere surround the point charge. Is this clear? The equipotential surface are interesting that from the definition of the potential of the given point of the electric field, it is clear that if we will take 2 points of the electric field with the different potentials, the difference potential of the electric field points will characterize the differences of their electrical energy, and phi1 minus phi2 is known as a voltage or potential difference. It will be equal to the work which has to be done to displace the unit of the point positive charge from one point of the electric field to another second point of the electric field. If we have the equipotential surface, phi1 minus phi2 will be equal, yes? Or their difference will be equal 0. So the charge which will be displaced across the equipotential surface will be not change its energy. or it is not necessary to be done a work to displace the charge from one point to another on the equipotential surface. Is this clear?
Yeah.
No, also we have to introduce the dipole. Dipole is the two same but opposite charge placed on the some distance from each other, which is known as the electric dipoles distance. So the LQ will be known as the dipole moment. It is a vector quantity and its direction usually used from negative to positive. No, a lot of the biological molecules have the dipole property. Among these molecules, we have to know the water. You know, water, due to the covalent bond between the oxygen and hydrogen atoms, oxygen became negative -2, and hydrogens on the other end became positive +2. So they have a dipole property, and we will call that the water is a dipole. Like this, waters, except water, the dipole property has the different compounds like the chloroform, methanol, some phospholipids, alpha spirals, calyx of the proteins, DNA molecules, and so and so. As the different biological molecules can be characterized by the dipole properties, and as it is known that the electric field arises into the living tissues, we are interested to determine how will be work dipole in the electric field. Let's introduce that we have a dipole into the homogeneous electric field. Now, what will be in this case? On the dipole will be influence two opposite but equal equivalent forces, which will be induce the rotation of the dipole. There will be known as the rotation moment, and dipole will be placed according to the direction of the force lines of the electric field. As these two forces in this case will be opposite directed and equal, dipole will be in the rest condition. Is it so? Let's introduce the dipole into the non-homogeneous electric field. In this case, on the dipole also will be influenced the rotating moment, but in this case, the F1 and F2 forces will be not equal each other. Force will be stronger, where the field will be stronger. That's why the rotated dipole will be not stay in the rest condition and will be moved in the direction to the stronger field. Is this clear?
Yeah, yes, makes sense.
Yes. And at last, we have to discuss what will be matter if we will place the positive charge, no, a negative charge, for example, ion, near the dipole, which may be, for example, the protein molecule. In this case, on the dipole, on the charge from the dipole properties on molecule will be influenced the forces, which superposition may be calculated by the rules of the vector algebra, and find the force which will be influenced on the point charge and direction where it will be moved. It is very important to predict the ion fluxes in the channels of the cellular membrane. We will discuss this later on the next semester. Now we have to discuss, as I know, now we have to discuss the different properties of the materials in the relation to the electrical field. Some of them are conductor, or what is a conductor? Do you know?
A substance that can conduct.
Substance.
Conduct the charge, or they are possible to develop the electrical current. Yes, why? Because they have a lot of the free charge. Can you name the examples of the conductors?
Ionic solutions.
No, iron, yes, but where? Metals, yes, materials which have the conductor properties. There are the metals, there are the electrolytes, yes, salt water, for example. But distilled water, no. And what is a non-conductor? Dielectrics, which are not conductor for the electricity, where cannot develop the electrical current. This means that they have a few charge, free charge. So yes, for example, pure water, distilled water, yes?
Yes.
Do you understand? Yes. Now let's introduce, if we will place the conductor into the outer electric field. Here is the outer electric field, beginning from here. And if we will place conductor into the electric field, what will be matter? There are, what is a conductor? They have, no, for example, we have a metal conductor. They have a lot of the free
Charge.
electrons. Now, what is the charge in the case of the metal?
The free electrons within the lattice.
Free electrons. So these electrons will be moved where? To positive pole. From where are beginning the first lines of the outer electric field? From positive to negative, yes? So electrons will move where? In direction opposite to the outer electric field, yes? That's why on this side of the metal piece will be growing negative charge, here will be grow the positive charge, and inside the metal piece will be developed the electrical field, which will be also directed from positive to negative, which will be directed against the outer electric field, or it will be annihilate the outer electric field, try to make it weaker. Is this clear?
Yeah.
Yes.
Okay. Now what about the dielectric placed into the electric field? For this, first of all, we have to know that the dielectric molecules may be dipole and non-dipole, yes? Which are dipole? For example, water molecule. And what will be matter with the water molecule in the electric field? This dipole will be orientated so that its positive charge will be directed to the negative pole of the electric field, yes? Or this will be also known as a polarization of the dielectric. If we will take non-polar dielectric, its distance between its positive and negative charge will be slightly increased, or it will be slightly polarized, and after also placed against the outer electrical fields. Or we will have the polarization of the dielectrics. Yes? Is it so?
Can you repeat the last part?
If we have the polar molecule, it will be placed against the outer electric field. It is polarization of the polar dielectric. If we have the non-polar dielectric, what means non-polar? That its positive and negative parts, nuclei and electrons, are in the same center, yes?
Yes.
If they will be placed in the electric field, they will be slightly polarized. Yes?
Yes, now it's clear.
Yeah.
Yes, and in this case, this slight polarization will be induced the polarization of the dielectric also. Okay, this is the polarization, effect of the polarization, and there we finish the electrostatics. Now we will discuss the electrodynamics. What is the electrodynamics? The science of the moving charge. You know that the moving series of the moving charge produce a current which is equal delta Q by delta T, or number of the charge which will be moved across the cross-section area of the conductor per unit of time. Yes? What is necessary for the current development? Now, what is necessary to develop the water current? Will be developed on the horizontal area, surface. Will be
There need to
developed
be a
on,
potential, electrical potential.
yes. So on the horizontal surface, the water current will be not developed. We need the differences in the height. For the development of the electric current, we need what? Also the point with the different energy or differences of the potential. Is this clear? Yes?
Yes.
You can see this picture. You can see here is the electrical circuit. This is voltage difference, and this is the ampere meter. You can see these electrons are moving and current develops when there are the differences of the potential, the circuit is closed. But when it is opened, no difference of potential, what you will see? The electrons are moving how? Look here, chaotically, and there are no current in the circuit. Do you see?
Yeah.
And look. Yes?
Yeah.
This is picture. No, there are what kind currents? Direct and alternating. Direct current is what? When the electrical current comes from a battery which supplies a constant flow of electricity in one direction. Yes, charge moves in one direction. And what is alternating current? Charge continuously change direction. Usually in our practice we use a 60 Hertz electrical alternating current. Yes, comes from the generator. The electromagnet is rotated in the permanent magnet. The direction of the current alternates once for every revolution. Is this clear?
Yeah.
No, Ohm's law, I not speak a very, I think everything you have to know this. Ohm's law, what is it? That when the electrical current moves across the conductor, what is it? This means that what? The energy is propagated across the conductor, yes? What is the necessary for it? Of course, voltage difference, yes? If the voltage difference will be equal 0, electrical current will be also equal 0. But electrical current will be also depending on the what? Properties of the conductors. They are not ideal material which will be not induce the losses of the energy. You have to remember the second law of the thermodynamics, yes? That all processes in the universe developed with the dissipation of the energy. That's why when the electrical current moves across the conductor, part of energy will be dissipated. And this amount of this dissipated energy for the given conductor will be depend on the electrical properties of the conductor known as a resistance, R. You can see that the resistance is depending on the geometrical characteristics of the conductor, increases with its length and decreases with its cross-section area. Also depends on its rho, unit of the volume, properties of the materials, and you see that this rho will be increased with the increase of the temperature. Is this clear?
Yeah. So for substances with higher resistances, you have more dissipated heat.
Yes, as thicker a conductor we have, as lower resistance we will have, as thinner, larger, yes? No, in this case, you have to remember, they are not shown here, but in your book there are the Joule-Lenz law, which shows that the Q, dissipated heat, is proportional to the resistance in the square. Yes? So when we have to make the heater, what kind resistors we will take? With high or low resistance?
High
resistance.
resistors.
High. But when we have to take the home electrical conductors, we have to
Low
take
resistance
low.
Low.
to
Yes.
burn down your
Yes.
house.
Okay. The high voltage cables are usually very wide, yes, have very big cross-section area. Why? To decrease the resistance and to decrease the dissipated energy. Is this clear? Loss of energy. Yes. No, I think you know the parallel and series of the connection of the conductors. I will not repeat, and I want to pay your attendance on the device capacitor, which we will also study in the second semester. They are the two conductor plates sandwiched by the dielectric, which if we will put this conductor, the capacitor into the direct current, will be circuit closed?
Circuit will be closer.
No, it's sandwiched by the dielectric. Can current go
No, current
across
doesn't
the
pass.
Oh,
dielectric?
okay,
No.
no.
Yes, but if it will be alternating current, it will, yes? And what
Yes.
about the lamp in this circuit after we will take out the electrical source? This capacitor will be charged and it will support the supply with energy to lamp, electrical lamp, and it will be lighted, yes? So what is the application of the capacitors? Storing of the energy, yes?
Yeah, yes.
Yes, the ability of the storing of energy, how many energy it can be stored, depends on the property of the capacitor, characteristic capacitance, which is depending on the geometrical properties of the capacitor, the area of its plates and distance between them, and also on the type of the dielectric between the plates.
Teacher, how
Is this
is
clear?
energy stored in this?
Yes, of course, it is
But
stored
how?
energy.
How?
How? Because the one plate will be charged negatively, another positively. Or we have differences of the potential, yes?
Yes, now I
Energy.
understand.
Yes. Okay. This is what you have to know. This is definitions, general definitions and law, which you had to study in school also, of the electricity. And also I want to give you a very small introduction in the magnetism also. I'm sorry that I close this. I have to continue. I will not explain you the whole magnetism, but introduction is the magnetism. And next week we will continue the magnetism. Do you see the presentation?
Yes, ma'am.
Yes, yes.
So the next portion which I have to explain the magnetism. No, like the electricity, magnetism is also a phenomena which was known from the very, very beginning, much more early as electricity was discovered. The people detected that sometimes the stones in the mountains attract the metal subjects, and also they show that the needle of this material will be also orientated in the one direction, and this was China's use it as a compass and used for the navigation. But the nature of the magnetic properties of the material was unclear up to the beginning 19th century, and it was explained only after the discovering of the electricity. The nature of the magnetism was explained by Oersted in the 1920 when he show that two conductors without current are not interacting with each other, but two conductors with current or repel each other or attract each other depending on the direction of the current. Also, it was shown when the Oersted placed the compass near the conductor with current, the compass changed its vice of compass, change its orientation, which mean that the conductor with current produces the magnetic field surround it. Is this clear?
Yeah, yes.
Yes. So, if we will remember the electricity, what is the source of the electric field?
Dipole.
Charges.
Charge, moving or non-moving. And now, what
Moving.
about the source of the magnetic field?
Charges as well.
Charge.
Electric
Electrical
field.
charge. But what kind charge? Only moving, yes, because only conductor with current produces the magnetic field. Yes? Is this clear?
Yes. Yes.
Yes. No, if we will continue our this material, you will see here is a lot of the examples of the source of the magnetic field, and among them there are the different conductor with the current, but there are also the permanent magnet and earth. If the source of the magnetic field is the moving charge, what is the source of the magnetic field in the permanent magnet and earth? For this, we will have to remember, we'll repeat this later, but today I will remember you that all materials contain the atoms, which contain what? the positive charge nuclei and
And
moving
electrons.
electrons surround them. They are spinning and orbital moving electrons. So each moving electron, spinning or orbital, it is the elemental source of the magnetic field. Yes?
Yes.
Yes. Yes, as the atoms are orientated chaotically, these magnetic fields will be also orientated chaotically and annihilate each other. But in some certain conditions, it's possible their disorientation and development of the permanent magnet. Is this clear? About this condition, we will discuss later. Now we have to know that in the magnetism, it was used the both kinds, north and south poles in relation to the north geographical north and south poles of the Earth, and it used said that the force lines of the magnetic fields are beginning on the North Pole and end in the South Pole. Yes? Yes?
Yeah.
The same poles repel each other and opposite poles attract each other. In the electricity, we was able to divide the charge, positive and negative. Can we divide the poles in the magnetic field?
No.
No. Why? Why? I will explain. Because the elementary source of the magnetic field is what? Single electron, yes? Spinning or orbital moving electron. And it, by its nature, produces the two-pole magnetic field. Yes? That's why it is impossible to divide the poles in the magnetic field. Is it clear? Yes? What are the characteristics? We discussed the characteristics of the electric field, the strength of the electric field and the potential difference. For the magnetic field, they are used the magnetic induction B and magnetic field strength H. What is the relation between the magnetic field, vector magnetic field and strength? In vacuum, B0 equal mu0 H0, where mu0 is a constant. Is this clear? We discussed that the electric field in different medium is different in comparison to vacuum. Is it so?
Yes, but what is H, teacher?
What? H is the strength
Yeah.
of the magnetic field. You see?
Yes.
Yes. We discussed that electric field in medium is different in comparison to vacuum. The same is to magnetic field. The magnetic field strength or vector induction B in medium will be changed in comparison to vacuum. And if for the electric field we will use the epsilon dielectric permeability, for the magnetic field we will use mu, the magnetic permeability of the medium. Is this clear? Yes?
Can
If you remember,
Yes.
last
Yes.
part?
Yes, ma'am.
what? If
Can
you
you?
remember,
Mhm.
magnetic field in the given medium B will be different in comparison to vacuum, or all medium are characterized by their magnetic permeability, like we discussed the dielectric permeability. Do you remember? Yes?
Yeah, yes.
Okay. Do you remember that I said that the epsilon always is more as 1? That means that the electric field in the given medium will be always weaker as in vacuum. Yes? Do you remember this?
Yes. So
Yes.
it's always positive, yeah.
According to the magnetic field, I have to set only that magnetic field not only always weaker in comparison to the vacuum. In some mediums it will be weaker, mu will be less as 1, and in some mediums it will be stronger, mu will be more as 1. Is this clear? About this we will discuss later. Is this clear? And if we will use B1, mu1, B2, mu2 will be what? B0 or H, we can write that H, B is equal mu0, H. This is relation between the vector induction and strength of the magnetic field in the given medium. Is this clear?
Yes. Yeah, yes.
Yes. And at last, we have to say what is the vector induction of the magnetic field. We can introduce if we will put the frame, conductor frame with current into the magnetic field. You will see that it will be rotated in the magnetic field if current is in it. And because from the side of magnetic field on it will be influence the rotating moment, like the electric field influenced on the dipole with the rotating moment, which will be proportional to the current intensity I, area of the frame, and angle between the direction of the current and the direction of the magnetic field. Is this clear? Yes? When the rotating moment will be maximal, when sinus alpha will be equal 1, or the frame will be perpendicular to the B. Yes?
Yes. Because the forces will be
And when it will be parallel, sine alpha will be equal 0, and the magnetic moment, rotating moment will be equal 0. Is this clear?
Yes.
Yes. Now, and once more, and I will finish my lecture. So let's repeat. What is the source of the electric field?
Charge.
Moving and non-moving. What is the source of the magnetic field?
Moving charges.
Moving charge. On which charge influences the magnetic field? To explain this, we have the Lorentz force, Lorentz formula, which shows, empirically was shown, that if we have the charge Q, which moves with the velocity v, in the magnetic field with the magnetic field induction B, in the direction that between the v velocity and B is the angle alpha, the Lorentz force is equal QVB sine alpha. In this case, if the charge is non-moving, what about the Lorentz force?
It will be minimal.
It will be
Minimal.
0.
Low.
Zero.
0, not low. V is 0, F is 0. Or magnetic field B will be not influenced on the non-moving charge. Is this clear? it needs a charge, but only moving charge. If the charge will be moved parallel to B, sine alpha is 0, force will be also equal 0. When Lorentz force will be maximal? When the charge moves perpendicular to the magnetic induction. Yes?
Yes, yes.
Yes. This is the force which influences from the side of the magnetic field on the moving charge. Now let's discuss the current. If we have the conductor with current and put it in the magnetic field, it influences on the from the side of the magnetic field, influences the ampere force, which, as you see, if in the conductor there are no electric current, will influence the magnetic field on the conductor without current? No. Is this clear?
Yes.
Yeah.
Yes. And we have to discuss the direction of the Lorentz and Ampere's law. It may be determined according to the left-hand rule, where the one finger shows the direction of the magnetic field, another finger shows the direction of the current or direction of the moving charge. In this case, the third finger will show the direction of the Lorentz or ampere force. Is this clear? There are three-dimensional space. The force, direction of the current, and direction of the magnetic field are perpendicular to each other. Do you see?
Yes.
Yes. And at last, we have to discuss the force, the magnetic field of the conductor with current. The conductor with current have what kind force lines? Cyclic force lines, which can be, direction of which can be determined by the right-hand rule, where the big finger shows the direction of the current, and these four fingers will show the direction of the vector induction of the magnetic field. Is this clear? As you see, these cyclic lines are distributed not homogeneously. Their density is more near the conductor, and after the distance between them increases. That means that the magnetic field will become weaker with the increase of the distance from the current. Is this clear? Yes?
Yes.
We can calculate the magnetic field vector induction by formula Biot-Savart-Laplace law, according which the induction of the magnetic field is proportional to the current intensity in the conductor and inversely proportional to the distance from the conductor in the square. Or in this case, like the case of the gravitation force field, like the electrical field, magnetic field is also what kind field? It is finite. Is it finite?
Magnetic field
No.
would be infinite.
Infinite. Magnetic field is also infinite because it is inversely proportional to the distance into the square. On the very large distance, it will be infinitely low, weak, but never will be equal 0. Is this clear?
Yes.
Yes. These portions you have to study for the next week. Is this clear?
Yes.
Yes.
Yes. This week, everybody has to have the oral test, including the respiration from the hydromechanics. Is this clear?
Diak.
Yes, you had enough time to study this. No, do you have a questions?
No, thank you.
Ara.
No, very good. See you later. Goodbye.
Terima banyak this.
Okay, goodbye. טוב, רוגו רח הרגיע.
שרוגו רח.
מאה.